Good afternoon, everyone who are present here. Now we are presenting a topic based on traffic sign detection using deep learning. We are going to explain how does deep learning implements in this traffic sign detection. Myself, Sai Vinay.
I am Ashika. Our project is about traffic sign detection using deep learning. This traffic sign detection algorithm can be integrated with the autonomous cars so that the cars will be able to identify the signs on the roads so that it can adjust the speeds and the direction accordingly. It increases the road safety, and also the autonomous cars will be able to adhere to the traffic rules and regulations of the government.
Now, what is traffic sign detection in deep learning? Traffic sign detection, like how does deep learning helps in this traffic sign detection? Using a CNN model, using the neural network, we take the help of this neural network and we are going to predict and recognize these traffic signs. Why use deep learning? Deep learning is a subset of machine learning because deep learning has a neural networks. In the neural networks has a capacity of detection and recognition. Deep learning has a large scope in the market now. It has a capability of almost like even humans can predict. So our models can predict. It almost predict it gives an accuracy nearly 97 to 98%. Before going to the topic, as we see, there are many cases in India around the world for the accident cases. The picture displayed here on the screen is a road accident by type of traffic rules violation in the year of during 2021. Due to overspeeding, accidents have occurred. 2,65,346 accidents have occurred. In fatalities means fatal accidents, 91,239. Injured is 2,55,663. Overall, in the year of 2020, 3,66,138 accidents have occurred due to this traffic sign violation. So we can directly say our objective in the project is like we're gonna help the society by giving a protection. For example, we can see in most of the India, humans will give the traffic sign, they will give the hand signs. But using our model, we can replace the humans. Our model predicts accurately, not 100%, near accurately. And why convolution neural network? Convolution neural network is a type of a deep learning model. This CNN is vastly used in image recognition and object detection precisely. And we have used many layers here, and I'm going to explain you how the CNN works. This is the CNN workflow. For example, I'll give an input. I'll give input. Assume that I'm giving an image of cat or dog or whatever it may be. I'll place a kernel or like filter in the sense I'm going to give the size of the filter. For example, if I give the 2:2 filter, this kernel, if this is an entire image, this kernel or filter will place or move full around the input. Input in the sense like image. This will extract the features in the sense edges or textures. Main features is going to extract the main features, and after this convolution layer, we're going to get the feature maps. In this convolution process, we'll get the feature maps. After feature maps, we're going to do the pooling layer. Pooling layer, we have max pooling and average pooling. What does a max pooling does? Max pooling, for example, if I get a feature map of 2:2 matrix, what does a max pooling do? Max pooling takes the maximum value of that. For example, in the matrix 2, 4, 6, 8, max pooling takes the 8 value, but which part has the highest feature, it will take that. After that, flattened layer. Fully connected layer is nothing but the dense layer. After the feature extraction from this convolution layer, we're gonna pass that feature into the output. How are we gonna pass the output of the feature? To the dense layers. Dense layer in the sense the networks are entirely connected, they are merged. For example, this model is inspired by our brain. In the brain, our neurons are internally connected. They pass the input, they pass the impulses, and the axon receives the input and will transform to the dendrites in the sense impulses where our actions are stored. Actions in the sense neurochemicals. So when we extract the features from this convolution layer and pooling layer, we're going to pass this to the dense layer. After this, we're gonna pass this to output, and we used softmax here. Why does we use the softmax? Because in this dense layer, the output will be in the form of 1D or 2D, sorry 3D or 4D. So softmax will convert that into like probability distribution. So after the output will come, we're gonna do the classification process. Data sets. For this traffic sign detection, there are many data sets like LISA. In the sense, LISA is specifically for American data set. We have Indian data set and German data set. We have used German data set. We have used 43 classes and more than 50,000 of images are present in our data set. Using this data set, we're going to recognize the traffic signs. What are the libraries used? NumPy. Why do we use NumPy? NumPy is basically for the array operations like array resizing or array manipulating. Mainly used for the array operations. Pandas is for the manipulation of the data. For example, if I store something in the data in the array, like if I give the data frame, whatever the data I've entered, it will be stored in the data frame. TensorFlow is one of the famous library. It was used in the neural networks like CNN. We mainly used this TensorFlow library in CNN. Keras is one of the famous API which is linked to the. Keras is like specifically designed for TensorFlow 80 and 20%, 80 for the training data, 20% for the test data. OpenCV is a library which is used for the image detection. It's open source. Okay, data augmentation. In a project, why do we use the data augmentation? For example, let us say I have trained my model with some data. Like I am given 50,000 images, and my model should predict all the 50,000 images. There is no rules that my model should predict all the 50,000 images. What does the data augmentation is do? That it basically expands the data, artificially expands the data set. It will apply the transformation, rotation, scaling, so that our model can predict even whatever the images that is not present in our data set. The main aim of the data augmentation is that it will improve our model, it will improve our model accuracy. Challenges of traffic sign recognition. Nowadays, challenges are like, for example, in bad weather or illumination occlusion, in the sense like sometimes in snow areas or lot of dust areas, traffic sign may be little covered. So that is the main challenge is there. But our model still predicts instead of if there is in that areas usually no humans will be present. So we can, with help of our model, we can implement this in the car so that it can 80 to 90% going to recognize there is a sign there. It will give a message to the drivers. There is a sign, so please follow it. Evaluation metrics. Of course, we have evaluation. We put the accuracy in KTuner. We have implemented the validation accuracy. We give the parameters as validation accuracy, so that it will predict what is the model accuracy, so that we can evaluate how a model is performing well. Applications of traffic sign recognition model. Of course, in the year following 5 to 10 years or 15 years, we can see nowadays in our Indians or in majority of in the world, electric vehicles are replacing and very smart cars are replacing. So that if this car take over the whatever this petrol and diesel, of course this system is going to implement in those cars. So this is the future. We can implement this model in those cars, so it will become a major asset to the society. So that we can help the people. Autonomous vehicles, driver assistance systems, and smart cities. Of course, as I told earlier, in Dubai, many nowadays we can see now also many technologies are implemented into that. Through this technology, we can futurize our technology. In the sense, we can improve our technology in many aspects. Currently, this technology is used by many cars. For example, BMW or Audi, Volkswagen. These cars are providing, but not completely. This technology is implemented in every cars. Accuracy of model. The model which we have trained is giving an accuracy of 97.83% for the German dataset model. Real world examples, as I showed earlier, there are many real world examples of traffic sign. Tesla, BMW, Mercedes-Benz, Ford, Audi. These cars are presently giving this technology, so that they're gonna you can ask me how are gonna test this. For example, they create a virtual environment. For example, to specifically test this type of cars, in their companies, they're going to create a virtual environment. In that environment, there is a system, they'll use some system so that they can evaluate if the system is working correctly or not. Conclusion. Of course, deep learning. Deep learning is, of course, in AI or ML or deep learning in future is going to take over. Take over in the sense, it will not replace the humans. The person who learns to use the AI tools will replace the normal humans. So With this kind of technologies, we can implement more and more like future in the conditions. Now we're gonna explain the code.
This is the code section of our model. Here we are importing the TensorFlow version 2.x. If it is not available, then the default version of the TensorFlow will be installed. And then here we are importing the libraries which are required for our model. Matplotlib, it is for plotting the graph, and CV2 is for the image manipulation, and NumPy is for array manipulation. These are the TensorFlow dependencies which are imported. Sequential is for the linear layer generation, and then two categorical is one-hot encoding, which will convert the label into one-hot encoding, and then optimizer that is used is the Adam optimizer. Model checkpoint is a callback function which will select the best hyperparameter, and image data generator is the one which will perform the image augmentation. Here we are loading the data set, that is the training data set and validation data set and the test data set. Xtrain, Xval and Xtext will be consisting of the images, whereas Ytrain, Yval and Ytest will be consisting of the corresponding labels. The shape functions gives the output as a number of images that are present, and the height and the width of each of the images that are present, and we have inputted the colored images, so the number of channels that are present is 3, that is the RGB color modeling. This is the graph of our data set. Our data set consists of 43 classes. Here we are pre-processing our image. We are converting the colored image into the grayscale image so that the computation becomes easy. We have used the equalize hist function where we are going to vary the intensities. Here we are performing the image augmentation. Here we are increasing the diversity of the image artificially.
As I said earlier, we are using data augmentation is an important part in our concept. We have used the image data generator augmentation. See, we have given the width shift range, height shift range, zoom range, shear range, rotation range. This basically given additional strength to our data set so that our model can predict even if the images are not present in our data set. It will basically increase the accuracy of our model.
This is the output of grayscale image. It is the model architecture. We have used 3 layers of convolution 2D and 3 layers of mask pooling in order to reduce the spatial dimension, and 3 layers of dropout are used in order to prevent the overfitting that is going to happen. We have also used the flatten layer in order to convert the 2D images into 1D array, and we have made use of softmax activation layer, which will convert the real model into the probability distribution. We have used the loss as a categorical cross entropy. Here it will make the model to select the highest probability so that it will return the image which is having the highest probability. Here we are installing the KTuner. The hyperparameters like kernel size, filters will all be set by the KTuner.
Here we installed KTuner. I'm going to explain why we have used KTuner here. KTuner is a library which gonna help in the tuning the hyperparameters. We have used a random search. In KTuner we have random search. Why do we use KTuner? Because for example there are many hyperparameters. For example, there is how many layers we have given, or how many shapes, or how many filters we have given. So this is gonna vary so that we're gonna tune. For example, I'm gonna give the range. See, in the code we have given the HP in the sense hyperparameter, filters on HP.int. I have given the filter minimum value 32 to 64. So what does the tuner does it? It's gonna tune, like it's gonna check with the values from 32 to 64. So basically it will tune and select the best value from 32 to 64. And we also given the kernel size hp.choice kernel 1 filter values 3 to 5. 3 to 5 in the sense 3 into 3 and 5 into 5. If the it will check 3 into 3, 4 into 4 and 5 into 5. It will select which is the best one. And similarly, we have given the 4 layers. We have applied the KTuner for kernel and filters, and we use activation function called relu, and we also use a dropout function. Dropout. Why do we use dropout function? Is that in order to prevent the model from getting overloaded, overfitted, so that our model doesn't train more and give the wrong predictions. KTuner. We have imported a random search. Random search is a function from the KTuner. What it does, it's gonna search which is the hyperparameter is best for our model. We have given the objective as validation accuracy. We have given the max scale as 10. And finally, we with the epochs, and we got the model.
It is the graph of training and validation accuracy, and it is a graph of training and validation loss. Here we are testing the model on the test data set. These are the probabilities which are generated. It will be in the range of 0 to 1. The one with the highest probability will be displayed. Yeah, this image has the highest probability, so this image is displayed.
Now we're going to show how our model works. We uploaded the image ahead only, so it's predicting ahead only. I'm going to show another few images. It's predicting as 30 kilometer per hour, so it's predicting correct. And I'm going to show a few images also, like for example stop symbol and right. Keep right. So our model is working correctly in the accuracy of 97%. Now I'm going to show how does OpenCV work here in the real time environment. Using OpenCV, we are showing the camera the traffic sign symbol, so it's predicting no entry, and we're going to show few images also. speed limit 30 km/h. Go straight or left. Skip right. This OpenCV, this feature, of course, it's pretty good, but not in a full accuracy. It will give, of course, it's gonna give some error, but we are. So we have showed using the Streamlit app how if we upload image it's predicting well, and using OpenCV also we have shown in the real time it's predicting well. I agree that it is not like 100% accuracy, it's giving a accuracy of 97%. So this is basically our project. Project main objective is to help the future generation. As I said earlier, in coming years, of course, the electric vehicles is going to boom. So in that electric vehicle, this system, if we implement this system, it's going to help the people and reduce. As I showed earlier in the picture, in India in the year of 2021, like nearly 4 lakh people have died. So due to traffic sign violation. So if we implement this system, we hope that our model helps in a good way, so that we can contribute to the people. So thank you.